Alright folks, so this is the last problem for week 1, and like it says in the description, this is a little bit more challenging than some of the other problems that you've encountered, but it's not impossible. And the first thing you have to do is you have to look at what it's trying to get you to figure out. So basically they want you to figure out the lengths of the sides of this area such that it is 1 acre. The problem is that all of the other units are in feet, so we have to somehow relate this area of an acre to feet. Well, luckily that's easily done. If we just do a quick internet search, we find that the 1 acre is 43,560 square feet just by doing a Google search. So if we start kind of thinking about our constraints, what we're interested in, we'll redraw this. We're interested in area E F D G. And what do we know? Well, we know that its area is 43,560 square feet. What else do we know? Well, if we look at the triangle AEF over here, we can determine the length EF. So if you think about this chord EF is opposite this 50-degree angle, and we know the adjacent side. So we need a function that relates adjacent and opposite. So again, we think so ka toa, and it is the tangent function that relates opposite and adjacent. So what do we know? Well, tangent of 50 degrees equals the opposite divided by the adjacent. Now we don't know the opposite, so I'm just going to list it as length EF divided by 500. And then per our usual procedure, we get EF by itself, length EF by itself, by multiplying both sides by 500. So we have 500 times, and again we'll just use the calculator to find the tangent of 50 degrees, or you could look it up in a trig table. So 50, yes, we're in degrees mode. Here's the tangent key. So 50 degrees has a tangent of about 1.19, and if you think about what that means, it means that the opposite side is about 20% longer than the adjacent side. So we'd expect the opposite side to be a little bit more than 500. So we'll say 1.19, and we'll close out of this. So I'm going to guess that 1.19 is going to be awfully close to 600. Let's find out. Multiply that by 500. Pretty close. 595.9 feet. So we can put another constraint on it. We know that this side is 595.9 feet. Now, you might think, well, look, we can figure out this angle here with its vertex at F, and we should be able to figure out the length of DG then. But the problem is that the length of DG depends on the length of ED. But the length of ED depends on getting to this area. So somehow we have to relate those lengths to this area. Well, this isn't really a very clean geometric shape, right? I mean, we know we've got a 90-degree corner here, and we've got a 90-degree corner here, but these angles are not 90 degrees. In fact, this angle in this corner here is going to be the complement to this 50-degree angle, right? So the angle in corner G by equal angles identity is the same as the angle in corner B, in vertex B, which is 40 degrees. And that means that if you think about this, if we were to draw in a perpendicular line here, this would have to be 50 degrees, this would have to be 90 degrees. So angle F here has got to be 140 degrees. We don't have any good way to deal with that. But if we draw in a perpendicular line here, we can break this into two areas. There's this area here, which is a rectangle. And if you think about the area of that rectangle, area and I'll put sub r for rectangle, equals, well, it's length times width, right? We already know the length, 595.9 feet, times distance, ED, which we have to solve for. Now think about the angle, think about the area of this triangle. So we'll come up with another area, A sub t. Well, what does it equal? Well, it equals its height of ED times its width. So let's think about its width. Well, if we look at this triangle closely, do we know that angle? Yeah, we do. We know that it's 50 degrees. So let's redraw that triangle. Okay, so I've just blown up this small little end section here. And by definition, I said that was 90 degrees. This is 50 degrees. I know that this is length ED on this side. I don't know any of the other lengths. And I'm trying to find that side opposite. Well, how do I relate length ED to the side opposite? Again, it's the tangent function. So what do I know? I know that tangent of 50 degrees equals this opposite side, which I'll call side O for now, equals the opposite side over the adjacent side, length ED. Getting the opposite side by itself, I get ED, which I don't know yet, times tangent of 50 degrees is going to equal that opposite side. So the area of that triangle is its height, which is ED, times its width, which is ED times the tangent of 50 degrees. And that entire quantity is over 2, because if you think about the triangle only actually occupies, half as much space as the equivalent rectangle would, right? This space is not occupied. So now that we know those two areas, how do we solve? Well, we know that A sub r plus A sub t must add to what? They must add to 43,560 square feet. So let's get them all in an equation and see if we can push this thing around a little bit. I'll come over here where we got some more space to work. 595 feet times ED plus ED times ED times tangent 50. And this whole thing is over 2 equals 43,560. So you can see what our manipulation has done for us is that it's gotten rid of all variables except for length ED. So now it's just simply a matter of algebraically turning the crank on this thing and getting an answer. So some creative rearranging is probably in order here. So I'm going to actually take this term, this really complex term here, and I'm going to write it first in the equation. So I'm going to write it all the way to the left. And I'm going to rearrange kind of the order in which these things are written. Because if you think about it, multiplication is commutative, right? We can move it from one position to another without changing its value. So I'm going to pull the tangent 50 and the 2 out in front and make it a coefficient. So tangent of 50 degrees, which again is a constant number, we can look it up in a table, divide it by 2. And then what is left? Well, ED times ED, which is just ED squared, plus 595, and I guess I dropped my 0.9 feet, times ED, equal, and then what I'm actually going to do is I'm actually going to subtract 43,560 from both sides. And the reason is I'm trying to get the right side of this equal to 0. So 43,560 square feet equals 0. Now, before we go any further, I want to clean this up a little bit by getting rid of the tangent 50. So let's pull that up on the calculator. So again, 50 degrees, I'm in degree mode. Take the tangent, and what was I doing to it in the formula? I was dividing by 2, so I'll divide by 2. So my coefficient for the ED squared term becomes 0.596, we'll say. We'll round it off. 0.596 ED squared plus 595.9 times ED minus 43,560 equals 0. Now, you may recognize this as a polynomial that would lend itself to solving through the quadratic equation. So I've pasted in the quadratic equation where you could essentially plug in each of these numbers, and through a lot of elbow grease you could use this to calculate the roots of this equation. So if you think about, in this case, negative b, well, b is the coefficient of the term that just has ed as opposed to ed squared. A is the coefficient of the squared term, this would be a, and then c is the coefficient of the term that does not have the variable in it, right? So we could write these in. Now, with numbers of this variety, that's going to be a lot of decimal places and a lot of number crunching. So a much more expedient way to approach this is to use just an online solver, and you can find there are lots of these on the internet. You can write your own in Excel. And so in this case, I've entered A, B, and C from our previous problem into the online solver, and you see that it gives you 2 roots. Remember that quadratic formula will always give you 2 roots unless it may give you 2 identical roots in some circumstances. Well, the 2 options for the length of line DE are either 68.4 feet or negative 1,068 feet. And because there are no negative marks on the ruler, we know that the second root here is an extraneous root. So the length of side DE of that triangle is about 68.4 feet, which answers the first part of the question, right? So we know, if we think about this area here, this is 68.4 feet in length. Now, the second question was they wanted you to figure out length DG. And again, we knew that length DG was basically length EF plus whatever this opposite side of the triangle was. Well, recall that length EF we've determined was 595.9 feet. And now that we know side ED of this triangle, we can find this opposite side. So again, it's going to be a tangent function. And the way we're going to calculate this is tangent 50 equals opposite over adjacent. So opposite's what we're trying to find. We now know that the adjacent side is 68.4 feet. So the opposite side is going to equal 68.4 times tangent of 50. So let's have a look at that. So 50 degrees, take the tangent, multiply it by 68.4, and the side of the triangle is about 81.5 feet. So 81.5 feet equals the opposite side. And then what is the length of DG? Well, DG is the sum, 595.9 plus 81.5. So we'll just add those up on the calculator.